So we are going to subtract fractions with unlike units using the strategy of creating equivalent fractions. Okay? So, here we go. We can do it, okay? As a reminder, remember, with fractions, it only happens if we're doing it together, okay? We're all in the same boat. As long as you guys are, or as long as I am patient with you guys, can you be patient with me?
Yeah. No, that's not very big. We have to be extra patient. Let's scrap.
Okay, don't scrap. So, unlike units. Let's jog our memory. Unlike units. Does that mean the denominators are the same or different? Ready? Go. Different. If it says unlike units, that means our bottom number is different. Okay? So we have to make equivalent fractions in order to subtract. Okay? So, check it out. Okay? Similar to what we were talking about with our adding fractions. Okay? Check out that subtraction sentence up there. 3 boys minus 1 girl. So, let's see. Oliver, Jackson, and Nika, could you both stand at the front for me, please? Sorry, I didn't ask. Is that okay if you guys are my example right now? Okay. Okay. The rest of you, please take this seriously. Okay, it's gonna be a silly question, but don't be like, yes, you can do that. Okay, you just answer my question for reals. Okay. Can I subtract 1 girl from that group up there?
No.
Again, class, take the question seriously. Okay? Do I have any girls up there to take away? No. Okay? Those are all big, strong boys. We love them. Yes, give them a round of applause if they come back. Okay? Sorry, I don't think you gave them the proper credit they deserve. Please give them a high five. A high five. Sorry. A round of applause. No, sit down. All right.
I gave all of them.
Stop. Okay. Round of applause. Sorry, not a high five. You can give them a high five later. So, in order to rewrite that sentence, I have to make it the same unit, right? So you guys might remember from last week, right? I can't subtract a girl from a boy. But I can subtract a person from people, right? So I can change it to 3 people, or let's even say, it even specifies boys and girls, right? So let's say 3 kids minus 1 kid. How many kids do I have now? Ready? Go.
2 kids.
2 kids.
I don't think they look like
Okay?
that. They look pretty good.
So, we can't subtract if they don't have the same unit, right? We can't take a girl away from a boy. They have to be the same unit, okay? All right, cool. So here, can I subtract 1/3 minus 1/2?
Yes.
Oh, sorry. Can I take 1/3 away from 1/2?
I mean, no.
No, I cannot. Okay? And we're going to learn how to do that. All right? So, do me a favor. You're going to take 1 minute. Think about what we did last week, okay? And you're going to talk to your elbow partner. Leela, you're going to turn around and talk to Charlie and Oliver, okay? You're going to talk to your elbow partner. Take what we learned last week and apply it to this. How can we subtract these guys, okay? Taking what we learned last week. How can you make like units and how can you subtract? Ready? Take 1 minute to talk about it. Ready? Go.
I think if you, I can't remember what we did last week. Yeah, we sandwich them. We smoosh them together, and then after we do that, we can add them. So this week we can sandwich and subtract.
Okay, 10 more seconds. I can tell you're starting to come down.
I'm forgetting what we did last week. All I know is that we sandwiched and we did adding. So this week I'm guessing we're going to sandwich and subtract.
All right. move to that desk and stand. I just don't want you to be in the way of Eddie and Matt.
Nice.
So if you want to stand, you can stand.
I mean, nobody's right.
Melina.
Here.
Alright, cool.
We'll stand by Henry.
No Melina area.
You can see.
Yeah. Okay. If you want to stand, you can stand.
I can stay.
Okay.
Where can I
Alright. Okay. Now that you're comfortable, can we move on?
Yes. If you want to stand, stand. Yes. Now I'm gonna stand over here.
Okay. Are we comfortable? Alright, here we go. So, I want to hear what you think. Okay? Go ahead and raise your hand if you would like to share what you think we're going to do in order to solve these subtraction problems. Jimena, go ahead.
I think we're just gonna be minusing like the bottom half,
Mm.
and leaving the top half.
That is an awesome guess. It's an awesome guess. It's a not quite there, but yes, that is a good guess. Eddie, go ahead.
Sandwich them like you're gonna add, but instead of adding them, you minus them.
I love it. Yes. Does anyone want to add to that? Henry, go ahead.
So, same thing as Eddie said, so sandwich them like that. And then, to make it easier, you could like even put the ones like in the other box like we did too.
Mm-hmm.
And then you could just cross out what you need to minus.
Okay. I like it. Donnie, did you want to add to that?
Maybe we sandwich them and then instead of adding, we subtract.
Okay. I like it. I think you guys are all on the right page. Okay. So here we go. I'm going to show you. You can put your hands down. Okay. I'm going to show you. So, like last time, we're going to start with 1/3. Alright. And we're going to show 1/4 over here. Okay. Familiar so far?
Yeah.
Alright. Thinking about what we know with equivalent fractions, okay? I've got to figure out what thirds and fourths have in common, right? Or 3 and 4 as my denominator have in common, right? So I know from last week, if I were to sandwich them, okay, I would get 12ths, right? Because we basically multiply the denominators together. So, you guessed it, I'm going to do the same thing, okay? So I'm going to sandwich them. Okay? So then this is the important bit. You have to know. We can all look at the
That was
clouds.
a school bus.
Okay.
Wow.
Alright, okay.
That's the ice cream
Take a second to look at the cloud.
truck. Wow. Ooh.
Say hi to the cloud.
Hi, Dad Fairy. It's Bob. Mr. Bob. Builder. Can he take some? No.
Dave, I want you back in your seat in 5, 4, 3, 2, 1, 0.
Bob.
Yes, honey.
Can I say something like that I thought of?
Yes.
So I think you have to put the those numbers from the one that was in the fourths
Mm-hmm.
into the thirds because you're minusing it by fourths.
That is a good guess, but I'm going to show you something first, and then I'll come back to that, okay? So, class, I see you, I promise. Just wait 1 sec, okay? So, now we have to focus on what we changed the fractions to, okay? So, tell me how to put those away because they're becoming distracting, okay? So, I need you guys to hear this, okay? So last time it didn't totally matter. It did matter, but it didn't matter what we changed the fractions to. But today it's going to super matter, okay? So 1/3 changed to 1, 2, 3, 4 out of 12, right? So 4/12. Okay? And 1/4 changed to 1, 2, 3 out of 12, or 3/12. Okay? So actually, what we're going to do, okay, is we're going to take away from this model, okay? Does anybody know why we have to take away from the first model and not the second? Or why we don't put them together to then subtract? Brady?
Well, wouldn't you have to do the bigger number every time? Because if you didn't, then... Well, yeah, no, you have to do the bigger number. You have to do that one because it's always going to be bigger. Because you're adding.
Yes. Yes. We're on the right track. Henry?
I think you have to put them in there because it's like fourths minus fourths. You know? Because like if you're gonna do it like that, you get.
So we have to take this away from this. Okay? So you guys are on the right track, but let me rephrase it, okay? So looking at the fraction, forget the models for a second. Go ahead and put your hands down, okay? Put your hands down. Looking at the fractions for a second, okay? The denominators still stay the same, okay? So 12ths are still going to be the unit. We changed everything to 12ths, okay? So they don't change back to anything else, or they don't become 0 or anything like that. Just like adding, okay? Just like adding, we have to subtract the numerators, the top numbers, okay? So class, what's 4 minus 3? Ready? Go. 1. So our answer is going to be 1/12, okay? So what I'm getting at is we have to subtract this from this, okay? So these models are actually just showing a subtraction problem in itself, okay? Whereas last time we kind of like put them together and stuff, this is just like, picture like a big subtraction symbol right here, okay? So we have, instead of seeing these together and thinking like, our brain is probably automatically thinking, oh, 7/12, right? Because that's what we were doing last week. But now, instead of putting them together, we're taking this away from this. So we're actually going to use this to show what we take away from this. So here's the crossing out part, okay? I have 4/12, so all of my work is going to be done on this model, okay? I have 4/12. Is 4/12 shown right here?
Yes.
Yeah, okay? So I'm taking away 3/12 from that. So here's 1/12, okay? 2/12, 3/12. What's left over? 1/12. And that's my answer. Do you see how this didn't really come into play with that?
Yeah.
This model's now just helping you to create the common factor, okay? The common denominator, all right? So it's a little different than last week. Yes, we're still sandwiching, but this model this time is just being used to show what's going on here, okay? Does that help a little bit?
Yeah.
Kind of? Okay. Charlie, Eddie, Lily.
So like 4/12 that you have
Jackson.
there,
You can go, Jackson.
and then you on the right number you saw how you say you subtracted 3 on it.
So basically, this one on the right is just showing you what to take away from this one. Okay. So yeah. Eddie. You wait till Jackson.
I just noticed that 3 times 4 is 12, and then you just have to flip them on this problem to get your answer.
Kind of. But there's a reason for that. And we'll talk more about that on Thursday. Okay? All right. But that's a great point, Eddie. Last thing, Lily, go ahead.
Is this the lesson that we forgot about?
No? Did we forget about a lesson?
Yeah,
No,
he
the
teaches us
lesson
that.
that we were told to never think about again.
Oh.
Who did that lesson?
Well, I clearly moved that one out of my brain. I don't know.
No, that was about addition.
No, that was something else. Yeah. All right.
Okay, because you said the day after, you're like, I was thinking about another lesson.
Oh, yeah. But that's no.
Forget what we said yesterday.
But, all right. Anyway, are we good on this for right now?
Yes,
Kind of. Okay. I'm going to do one more, and I think it'll make more sense. Okay?
Okay.
So, now we have 1/2 and 1/5. Okay? Can you wait 1 sec here? Okay? I'm going to show you something really quick. Okay? I know I'm putting this one the wrong way. Okay? I know that. So don't say you're doing it wrong. Okay? Because I know I am. All right?
You're wrong.
We have 1/2 minus 1/5. Okay? 1/2 minus 1/5. Okay? Don't say the answer yet. Which one is bigger, 1/2 or 1/5? Don't say it. Which fraction is bigger, 1/2 or 1/5? Ready? Go.
1/2.
1/2. Okay? 1/2. Don't let the 5 confuse you. Okay? Yes, the digit 5 is bigger than the digit 2. But in this case, 1/2 is bigger than 1/5. Okay? So now let me fix Let me fix this guy. Okay, so hold on. Whoa, hold on. We're getting crazy right now.
Sorry. I just thought
Okay, so same deal. The reason I flipped it was to show you which one's bigger. Okay, so same deal. I gotta create a common denominator. Okay, I gotta create equivalent fractions so that I can subtract. So I have to change 1/2 and 1/5 into something else. So to do that, I'm going to sandwich them. Okay, so 1, 2, 3, 4, 5. 1, 2. Okay? So I've done my sandwiching. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So my new denominator is what? Ready? Go.
10.
Good. 10. Okay? So it becomes something tenths minus something tenths. Okay? So over here I have 1, 2, 3, 4, 5 tenths. And over here I have 1, 2 tenths. Okay?
Whoa, I guess.
So this second model is showing me what I have to take away from the first model. So how many tenths am I going to take away from the first model? Ready? Go.
2.
2. Yes. Okay. 1, 2. I have 1, 2, 3 tenths left over. So my answer is 3 tenths. Okay. Now, really quick. I see your hands. I promise I will get to you. I want to show you something really quick. Okay. Remember at the beginning of this problem I said we made sure we knew that 1/2 was bigger than 1/5, right? Yes?
Yeah.
All right. In a subtraction problem, we know 2 things. Okay? Right now, as 5th graders, right, we know that we can't take a bigger number away from a smaller number, right? In the future, yes, you can do that. But right now, we know that we are not able to do this. Okay? Right? You guys agree?
Yes.
Okay? Some of you may know how to do that. But right now in 5th grade, I don't need you to know how to do this yet. Okay? So right now in your brain, make sure you know, oh, I can't take a bigger number away from a smaller number. Okay? So that's the first thing we know. We also know, okay, that the order of subtraction matters, right? So, for example, with those same numbers, what do I get with 5 minus 3? Ready, go? 2. Okay? But if I were to do 3 minus 5, would I get a different answer?
Yes.
Yes. Okay? You guys don't know what that answer would be yet, and that's fine. But bottom line, we know, okay? I'm not gonna get the answer from you, okay? Bottom line, we know that we have to subtract the smaller number from the bigger number, always, okay? So that's why I made it a point to show you that 1/2 is bigger than 1/5, okay? Because we have to take this number away from this number, okay? So that's why I'm showing you that. It's because this model is showing what we're taking away from this model, all right? Because it has to be, with subtraction, it has to be left to right. With addition, does it matter what order you add them in? No, okay? So it has to be left to right. So we have to take this one away from this one. Okay? Is everybody getting what I'm getting at? Okay, Bonnie.
So if you're like a girl or someone who likes to bake, you could think of it as measuring cups because like 1/2 is much bigger than a 5th because the size like a half would be about that big, or that would be a whole, and then a half would be just a little bit smaller, but a 5th would be about that big.
Totally, yeah. Henry.
I know like the answer to that problem, but it's not tricky. It's not like anything. I'm just like gonna say it. It's like I remember this in 2nd grade. It's the backwards where it's so it's a backwards thing. So it's like 5 minus 3 equals 2. So it's 2 equals 3.
Oh. No, not quite. But that is a good point. Yes, you can write an addition, subtraction, multiplication, or division sentence backwards. What he's talking about is writing it like this. Okay, you technically can write it like that, but it's more correct to put it on the right side. Okay, but this is still saying 5 minus 3 equals 2. So, yeah. Okay. All right. Anyway, we're moving on from that. I am only wanting questions about this. Okay. Okay. Brady, is it about this? Okay, go.
So for the 1/2 and then the 1/5, could you like flip this to in the 5 and then do it?
Nope. Because
you-
those are two different units, right? Like they're two, like kind of what Donna was saying, right? Like if you're thinking of like measuring cups, right? 1/2 is just always bigger than 1/5. Like you don't want to change the value of it, right? This problem is asking us to do 1/2 minus 1/5. If the problem was saying 1/5 minus 1/2, then we would do that, but we can't just flip them, you know?
Well, can't you like multiply them together and then you would get the tenths of? But like, wouldn't you like? Can't you like put the 5 up to the left, top, like up the 5 up to the top left and then the 2 up to the top right?
Oh, I see what you're
Because
saying.
You know that since you're gonna.
For something like this, sure, but it's not going to work for every problem. Okay? Like especially when we go to problems that have instead like 1/2 minus 3/5, that's not going to work. Okay? For when we have a numerator as 1, sure, technically, but not quite.
Can't it still work if you go like, because you know that 2 times 5 is 10, and then you have 3 out of 5. Couldn't you just like, since like I know like fractions, like can I just like I know that that's 6 times.
So why do you know it's 6 tenths?
Because like in my mind I can just like picture the for this one I'd picture 10 grid since it's the easiest thing, and then I'd go 2, 4, 6, and that'd be 10.
I see. Okay. Yes. If that works for you, yes. Okay. But can you also kind of see what I'm like? Just as we go along, also kind of pay attention to what. I know the models are not ideal for some of us, but they are for others too. So we want to make sure that we're kind of like, you know. But I promise you on Thursday, okay? Thursday is all going to be like, how do I do this all numerically without the model, right? So that's what Thursday is going to be, okay? But we're still going to work with the model today, tomorrow, and a little bit on Wednesday, okay? All right. Cool. Cool. Can you guys try this one with your elbow partner? Yes? No?
Yeah, maybe so.
Okay. Cool. Yes, Charlie? Not yet. Not yet. Back. Put the other way. All I asked you was, can you try this with your elbow partner? Did I say on your whiteboard, anything like that? No. Yes, Lily. How you always do it with your elbow partner? Okay? How you guys always communicate? Just that's, you know, not anything new. Huh?
You said how you guys always communicate.
Yeah, I mean, you guys are great, you work together, okay? Okay. So yes or no, can you try this with your elbow partner?
Yes.
Yes, all right.
Wait, then what about Lila?
Okay, I got it. Don't worry. Don't worry. Leela, who are you going to work with? Okay. All right, everybody good?
Yeah.
Just answer the question yes or no. Can you solve this with your elbow partner?
Yes. Probably. Most likely.
Yes.
Yes,
Okay.
God.
When I ask that question, can you say yes, please? Can you solve this with your elbow partner?
Yes.
Great. When I say go, please take out your whiteboard. Your desk needs to be closed right now, though. Your hands are up. Okay. You have 3 minutes. Ready? Go.
I think I know. This way. I did it mentally in my brain and I got 0 12.
Okay.
Is that right?
I don't know. I would go through and do the model and everything and talk with Kira too. Okay? fraction in the first model, second fraction in the second model. I would split them. So do 2/3 over here, but like vertical, okay? And do 1/4 over here, horizontal. Just so we're kind of all on the same page.
Am I going with
So you're 2/3 minus 1/4. This is your 2/3. This is your 1/4, right? When you sandwich them, what unit did you get? Good. Why did you flip them? Yeah. Why did you put 3/12 over here and 8/12 over here?
Okay, so the difference is
Gotta stay in the same order, left to right. Okay. Oh, wait, hold on. What should go here? Yeah, there you go. Yes. No. Why are you flipping them? This is your 8/12. This is your 3/12. Why are you flipping them? I don't know. What doesn't make sense? Why not? So your two thirds change to what fraction? Yeah. So it just stays on the left, right? You showed your 2/3 on the left. So it's the same fraction. It's just it looks a little different, right? Yeah. So over here, your 1/4 changed to what? Okay. So just keep them. This on the left, this on the right, this on the left, this on the right, right? Like just keep them the same. For some reason, you were flipping them in your head. And I was wondering how you got that. Because then when I said to write it like this, and you're like, oh, I should put the 8/12 over here. I'm like, no, just keep it all on the left, right? 8/12 is on the left, 3/12 is on the left, right? Do you get what I'm saying? Okay, all right. Can you solve that for me? 8/12 and 3/12.
Did you get 5/12?
All right, my timer's going off, so let's see how you guys did.
Miss, for this one, it was 4 times 2 equals 8, and then you'd put it where the 2 was, and then 8 times 1, and then you'd put it where 6 is.
Yes. Yes, but you'll see how that connects on Thursday. Okay. All right, are we good?
I just drew Mr. Krabs.
Okay. Markers are down. Okay. Awesome. Thank you, Jerry. Cool. Markers are down on the desk. I got Jackson has his hands together. Thank you, Oliver and Charlie. Beautiful. All right. We got 2/3. We got 1/4. Okay. 2/3 on the left, 1/4 on the right. They just all stay in their same spot. Okay. So then after that, I need to make like units, so I sandwich them. Okay. So 1, 2, 3, 4. 1, 2, 3. Everybody with me on that?
Yes.
All of your sandwiching looked beautiful. It looks beautiful. Can you wait till this problem's done, Lily? Okay. All right. So now, okay, my 2/3 is still technically 2/3. The value is still the same, right? But it is represented in a different way. What's the new denominator, friends? Ready? Go.
8, 12.
The new denominator. What's the new denominator? Go. 12s. Okay? 12s. Both of the fractions change to 12s. Okay, they both change to 12s. Out of 12, how many are colored in the first model? Ready? Go. 8. Yes. So 2/3 change to 8/12. Is everybody getting that?
Yes.
All right, cool. After we sandwich them, it now changed. Okay, it now changed. So then over here, my 1/4 changed to how many 12s? Ready? Go.
3.
3. How many out of 12 are colored in over here?
3.
3. Okay, so it's 3/12. Remember, this model is showing how much to take away from this model. Okay? So after you sandwich them, guys, your whole focus is just over here. Okay? Like you can almost ignore this guy, okay? Your whole focus is now on that first model. So I have to take 3/12 away from my 8/12. So that's where I do some fun crossing out, right? 1, 2, 3, okay? And what I have left over is what I have left over, right? So 1, 2, 3, 4, 5, 12 is my answer. Okay?
Yes.
Okay. Questions on that? Lily, go.
This one is when you think of like which one's bigger, just think of like 1 to 100 backwards. Because technically 100 is smaller than 100.
Oh, I see what you're saying. Okay. Like a bigger denominator usually is a smaller
Yeah.
amount. Yes.
Yeah.
Yeah.
So that's what I do. Because I think it's 1 to 100 backwards.
Okay.
100 to 1 because one is the whole,
Mhm.
and when you the higher you get, the smaller you get,
Mhm.
and also smaller.
Yes. Charlie.
It's kind of like a book if you really look at it, and also like the other page, like you like use those words like.
Yeah, kind of. If you want to think of it that way, go for it. Yes. Okay. That might be a little confusing, but like to other people. But if that makes sense to you, go for it. All right. Any other questions on this problem?
No.
All right. How are we feeling about this?
Good.
Pretty much the same thing. The only thing is we take this one away from that one, right? And that's what subtraction is, right? We take the second number away from the first number. If I have 24 minus 10, I'm taking the second number away from the first number, right?
Yeah.
Okay, do me a favor, put your caps on your markers. Look up here. I should not have gotten no response to that, okay? In normal subtraction, right, we take the second number away from the first number, right? There it is. Okay, so take this number away from this number. What do you get? Ready? Go.
14.
14. Good. It's the same thing here. I take this number away from this number. I take this number away from this number, and I get my final answer. Okay? You ready to try one on your own?
Yes.
Okay. Let's do it. It's a little tricky, but you can do it. Okay? Let's see how much we have. Yeah. All right. Go ahead and try this on your own. You may erase and start. You have 3 minutes. Ready? Go.
Ready, go.
You guys are doing great. When you're done, I want that board flipped over to the brown side. Okay? Start with 2 models. Start with 2 models. Show the first fraction in the first model, second fraction in the second model, sandwich them, and go from there. I'll let you think about that one, Luke. Yeah, we don't need to be whistling or anything. When I say show, even if you weren't able to finish, go ahead and show me right here. Ready?
Yep.
Show. Right here, yeah. Yes, class. Good. Good. Drew, what'd you get? 3/14. If you got 3/14, give yourself a pat on the back.
Dang it.
Okay. That was pretty dang good. I don't even think we really need to look at that. That was good. Can you wait until Lily gets back? Okay. All right. Awesome. Erase your board. Flip it over. Ready? Go.
Miss Witt, I got this bag and I just got it yesterday and it's right now it's only 4 feet when it's supposed to be up to 5 feet.
Wow. That's crazy.
Like that tall too.
All right. Flip over your board. Make sure it's erased and flipped over. There you go. Faster. Come on. Come on. Erase. Flip it over. Okay. Here we go. Last one. I want you guys to do this one on your own as well, just to make sure we're good. Okay?
Okay.
As soon as I put it up there, you can start. Are you ready?
Yes, ma'am.
Okay. Oh, it's not up there. Hold on. Flip it over.
I saw.
Flip it over.
I don't think that was on purpose, Miss Witt.
No, it really was an accident. Okay. The board's on the brown side.
You tricked.
Because we heard the click and
You lost cool points. I didn't even.
Go. I lost 4 points.
No, you didn't.
My reputation is all I have, my friends.
You're nice.
Nope,
Oh,
you lost.
thanks.
Nope, you lost your reputation.
She farted.
What?
She's like, what?
That was me that said
I did not fart.
Miss Witt, that is so it's like I did not fart.
That was not kind.
Henry's lost his kindness reputation. Yeah, and then there's Henry saying that. Yeah.
Drink your farts.
Hey, stop, please. I want you to keep going on the problem. No more comments.
Are you checking them?
No, that's okay. I'm gonna have you show me again in a little bit. We got about 1 more minute.
Oh no, maybe.
Oh,
And
minuto.
are we gonna watch Doug today?
Yes. Did we not lunch?
Yeah, we did. Verdict. Can dogs understand you? That was like such a good one. We did. I know, I wasn't here. Sucks to suck.
Sucks to be you. Does to suck.
No problem.
Mr. Schaefer.
Okay, I'm coming to you in about 30 seconds. How we doing?
Horrible, I
Failed this class.
Oh my, Brady. You failed
I know how to turn an F into an A.
Okay,
You have to be F minus
it's hard work and perseverance. That's how you turn an F into an A.
You just turn it upside down, then just switch a couple of the.
No, you just go.
Bro. Okay, when I say show me. Ready? Show me. Right here. Okay.
I got 12.
Okay, put a nap. Okay. Here we go.
Is it a very tough answer?
I got 4 30s.
Okay, here we go. Start with 4/5. What do I show in my other model? 2/3. Okay. Cool. Am I starting off okay?
Yeah.
Awesome. All right. Cool. Next, I sandwich them, right? Okay. 1, 2.
Oh, I see what I did wrong.
Thank you, Molina, for having your marker down. Okay, thank you, Drew. Thank you, Maddie, for your attention. Thank you, Mika. All right. So after I sandwich them, I get my new unit, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is my new unit, which is my new denominator, okay? So it's something 15ths minus something 15ths, okay? Then I count how many are colored in, okay? So I know that 15 minus 3, okay, is 12. So 12 out of 15 are colored in, right? Because all but 3 are colored in. But if you needed to go back and count them individually, that's okay. You can do that. Okay? Over here, I know that 15 minus 5 is 10. So that means 10 15ths are colored in over here. Okay? And class, what is 12 minus 10? Ready? Go. 2 15ths is my answer. I did that numerically, but on your homework, I do want you to show how to do it on the model as well, which just means crossing out, okay? So I'm going to cross out 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 2 left over, so 2 15ths is my answer, okay? How'd we do?
Decent. Terrible.
Okay?
I did terrible.
If
Okay.
you say good is good, I farted.
I want to erase it.
Okay.
I'm kidding.
Please erase your board when I say go. And put them away and wait patiently, okay? Ready?